So let's continue and do some more problems of this more advanced type where we're going to have to first solve it for the square root term. And then from there, we can square each side of this. So let's just add 12 to the other side. We get that 5 is the square root of 3 plus 20z. And since we've solved for the square root term, let's square everything. So 5 squared is 25. And here the square and the square root cancel. So you get 3 plus 20z. And let's subtract 3 on each side so that we could solve for z. And so you get 22 is 20z. And dividing everything by 20, you would get 20 over 22. Or excuse me, the other way around, 22 over 20, which simplifies to 11 over 10. And so that's our z value, or at least what we think is the z value. And by the way, 11 tenths is really just 1.1. So let's plug that back in and see if we get something that makes sense. So we can check this. Let me just make just a bit more room here. And we're just plugging in, z is 11 over 10. So we have that minus 7. And I'll add the 12 to the other side. It won't change anything. And we get the square root of 3 plus 20 times 11 tenths. And over here we get 5 is the square root. The 20 over 10 just becomes a 2. So you get 3 plus 2 times 11, or 3 plus 22. But this is just the square root of 25, which does equal 5, and so this is definitely the right answer. So 11 tenths, or this 1.1, is choice letter A, and that will be the correct answer. So let's do a couple more of these, and these will be a little bit more advanced. But the strategy will remain the same though, but they just take a little bit longer to solve, and we need to first solve for that square root term, so let's add 2y to each side of this equation. So you get the square root of 7y squared plus 15y is equal to 5 plus 3y. And now we can square both sides. And we know squaring the square root will cancel it out. So we get 7y squared plus 15y. And over here, I'll rewrite it as this expression, this binomial. We'll rewrite it twice so that we're squaring it. And after rewriting the left-hand side, we can multiply out the right. 5 times 5 is 25. 5 times 3y is 15y, but we do that twice. So 15y and 15y is really 30y. And then 3y and 3y multiplied together gives us 9y squared. And let's solve it for y, but this is a quadratic, and we'll have to set one side equal to 0. So let's set the left-hand side equal to 0 so that the coefficient on y squared can remain positive. So subtract 7y squared, subtract this 15y on each side. And when we do all this, let me just make a little bit more room here. We get 0 on the left. I'll write it over here. Let's change colors. So 0 is, let's write the y squared terms first. So 2y squared. And then 30y minus 15y, so plus 15y, and then we have plus 25. So writing it in standard form is usually just good practice. And at this point, we can do some factoring, or we could use the quadratic formula. And most of these problems are going to be set up so that they can be factored, but if you're not sure or you don't want to go through the grouping method, you can always use the quadratic formula. So let's use our grouping method here. We're going to separate the 15y into two different terms. I'll call them ax and bx. And then once we have 4 terms, we can group them in pairs and pull out the greatest common factor. And these coefficients a and b, they have to recombine to be 15. Oh, and I used x, but I meant y there. They have to recombine to be 15 so that the coefficient stays the same. And they're going to multiply to the product of the coefficient on y squared and the constant term. So they'll multiply to 2 times 25, which in this case is 50. So we're looking for two numbers that multiply to 50 and adds to 15. So let's look at the possible factor pairs of 50. We can do 1 and 50. We can do 2 and 25. We can do 10 and 5. And 10 and 5 is going to work because 10 plus 5 does equal 15. So that satisfies our condition where they multiply to 50 and add to 15. So now let's rewrite this equation. We're going to have 0 is 2y squared, but now we have plus 10y plus 5y plus 25. And it doesn't matter which one you write first. But now we will factor by grouping. We'll pair the first two and the second two together, and we'll pull out the greatest common factor from each. So from this one, we can pull out a 2y, and so we have y plus 5. And you can always check this by redistributing. And for the 5y plus 25, we can pull out a 5, and you get y plus 5 on the inside. And you can always tell that you're doing it right if these end up being the same expression. Let me make some more room here. And continuing over here, we have that 0 is, well, we're going to factor out the y plus 5 from each of these two terms. So you get y plus 5. And from here, you're left with a 2y. And here, you're left with plus 5. And now, since it's factored, we could use our zero product property. We know for at least this one that y is negative 5. And for this one, we can set it equal to 0. So we have 2y plus 5 is 0. And subtracting 5 on each side and dividing by 2, we get minus 5 halves. So these are the two answers that we think are correct, but we're going to have to check them. So we're going to have to plug it back into the original equation. And let me rewrite that. So it's square root 7y squared plus 15y minus 2y, but honestly, let's just move that to the other side. So you get 5 plus 3y. And those two solutions we got, negative 5 and minus 5 halves. So we'll check those. Check y is negative 5 and minus 5 halves. So we can start with negative 5. We get the square root of 7 times negative 5 squared would be positive 25. And 7 times that would be 175. But then we have 15 times negative 5. 5 and 10 make 50. 5 and 5 make 25. And 50 plus 25 is 75, but we want the opposite of that, so we are subtracting 75. And this will be equal to 5 plus 3 times negative 5, which is a negative number. 5 minus 15 would be negative 10. And over here, you get the square root of 100, which is 10. So these are not going to be equal, which means we can eliminate this negative 5. And from here, let's just check the other one, just so that we can make sure it doesn't have no solutions. So y is minus 5 halves. We will take the square root of 7 times that number squared. So we have 7, and it will become positive, but we'll have 25 in our numerator and 4 in our denominator. And then we have plus 15 times minus 5 halves. And we're going to see, does this equal 5 plus 3 times minus 5 halves? So this one, we've got a lot of fractions we'll need to simplify, but we can do this. So for this term here, we have 7 times 25, which is 175, and that's over 4. And this one becomes minus 75 over 2. But let's give it a denominator of 4, so that becomes minus 150 over 4. And over here we have 5, or let's put that over 2. So 10 over 2. And then we have minus 15 over 2. But you can see this is also going to be a negative number. So under here we have 25 and 4, but over here we have minus 5 halves. And this simplifies to 5 halves, since you would take the square root of the top and the square root of the bottom. And square root of 25 is 5, square root of 4 is 2. But you can see 5 halves is not the same as minus 5 halves. So this one, even though we got two solutions that we thought could be solutions, when we checked them, neither of them worked. And this is why it's important to check both answers, because sometimes there are no solutions to this. There are no y values as real numbers that could make this true. So one mistake that you don't want to make is when you eliminate one solution to assume that the other solution must be correct, because sometimes both of them will not work. Now, let's do one final problem, and then, like I mentioned in the next video, we'll look at these extraneous solutions of these equations and understand why you end up with that. Why do you end up with values that when you check it, it doesn't work? Because all of our math was valid, but sometimes you end up with those. And we'll talk about that in greater depth in the next video. Now, for this one, we have two square root terms. And what we can do, since we need to isolate the square root term, well, in this case, we can just add the square root term, or one of them, to the other side. And that way, we're essentially isolating both of them at the same time. And from here, we can just square both sides of the equation, since in both cases, the square root and the square will cancel. And we get 4x minus 3 on the left and 9 minus 2x on the right. Now, let's solve this linear equation. We could add 2x to each side, and we could add 3 to each side, so that we get 6x is 12. And then dividing everything by 6, we get x is 2. So now that we have an answer, we need to plug this back in and make sure it makes sense. So let's check this. We need to check that x does in fact equal 2. So we have the square root of 4 times 2 minus 3. And then we'll subtract the square root of 9 minus 2 times 2. And for this one, we get the square root of 8 minus 3, which is 5. And for this one, we get 9 minus 4, which is also 5. And something minus the same thing, or when we subtract something from itself, essentially, we always get back 0. Square root of 5 minus the square root of 5 is 0. And so this worked. We got an answer that, when we checked it, actually made sense. So we can feel confident that, for this one, letter B is the correct answer.